Hello everyone. Well, we're on to week number 6 and homework assignment number 5. And this week we're looking at what we call the upper level diagram, or we're going to be plotting what we've referred to as the sounding in the atmosphere. In other words, when we launch a balloon and put it through the atmosphere, it measures temperature, humidity, or the amount of moisture in the air, and we measure that as dew point, and also the wind speed and direction. We track those balloons. And this is where we plotted it, which is on what's called a Skew T log P diagram. And what that means is here, I know it's a lot of big words, don't let that freak you out. We're just going to get very simple here to give you an idea of what this looks like. Here we're looking at pressure on this picture, the first page. We have horizontal lines represent pressure. Down at the bottom we have about 1,000 millibars, and that represents the surface. So we're going up vertically this way. And you see pressure decreases, and up at the top here we have about 300 millibars, and we measure it in millibars. And so this is going up through the atmosphere, and this is where the balloon would be traced. That takes care of the pressure. It's the blue horizontal line starting out at the bottom again with 1,000 millibars up to 300 millibars, and it goes on up higher than that. But we really don't need to go much higher than that to get a good idea of what's happening in the atmosphere. The next the next part we look at is the temperature. We want to plot temperatures. Temperatures get warmest down here in this corner in the lower right, and they get colder as we go towards the upper left. And the lines, or the equal lines of temperature, are skewed at an angle, and that is a 45-degree angle. So we start out here at about 45 degrees Celsius, and Celsius down to 30, or 40, 30, 20, 10, 0, things like that. So as you go up in the atmosphere, the temperature is decreasing, but you notice it's at an angle. And there's reasons for this. We're not going to worry about those reasons here for the level of this class. This is, again, just an introduction to what we do with that radio sound information. Now here's a look at an actual balloon sounding as it's gone through the atmosphere. We took the measurements from that and we've put it on a chart. And the red line here represents the temperature as the balloon was going up through the atmosphere, and it plots that temperature. The next line over, this green line, represents the dew point temperature. So you can see how they change. You will never ever find a dew point temperature that is warmer than the air temperature. That is physically impossible. You can reach saturation and have a temperature that equals the dew point temperature at 100% humidity, but in the atmosphere it cannot happen. Under certain scientific conditions in a controlled environment, we can have higher than 100% humidity, but that's very hard to do and requires special things. Does not happen in the real world in the atmosphere. Also on this chart, as I said, we gather the wind speed and direction. This direction, this is not like looking up. It's not watching the balloon going up. This is still, the top of the page is north. The right side of the page is east. The bottom side of the page is south. This is west. So we're plotting this wind speed and direction. The direction as we go up through the atmosphere. So if this is east over here, what direction is this wind blowing from? Remember, the stick, the main stick of the flag, points to the direction the wind is blowing from. And so that's what we want to know. What direction is the wind blowing from, and how fast are they blowing? Remember how we gather this information, the speed and whatnot from that. So again, what we want to do here, what we're looking for in the assignment, is what is the temperature at the surface in Celsius, what is the dew point temperature in the Celsius. And we go back up to our diagram and we look for the bottom temperature. Look where it reads here. Remember, this line is 30 degrees Celsius, this is 20, this is 10, and we interpolate in between to what those temperatures would be. And again, we're looking for the air temperature at the surface and the dew point temperature at the surface. And the next one is 700 millibars. We're looking up here at 700 millibars, and the next one is 500 millibars. You find that one on your own. And then you have to get the wind speed and the direction for each one of those heights as well. And that just as all we're asking you to do is to look for these values on this chart. And again, if you need to, repeat this video or give me a holler through the email or send me a message if you need some further explanation. Happy to do that. Have a great time.